Hey guys, this is Mr. Gran and this is 8.5 Rational Equations. In this lesson, this video, we're going to talk about solving rational equations and then determining whether or not these solutions are extraneous. All right, so here's our steps for solving rational equations. We are going to figure out what the least common denominator is and multiply all terms of the equation by that least common denominator so that we don't have to deal with fractions anymore. We're going to cancel out the denominators. After that, we're going to isolate x. Now, this could be linear algebra. We could have to use some quadratic strategies. But we're solving for x. And then we're going to check to make sure it's not an extraneous. So it should work, but remember that these are ones that when you solve it, it makes sense that you find this answer for x, but it doesn't work in the original equation. In this case, it's going to be if the answers land on our domain restrictions. All right, so for our first example, solving this one. Now, with these, the denominators already match, and so really all we need to do is get the numerators to match, right? Before we do that, though, we should note that x cannot equal a positive 3, because if I plugged in a 3, the denominators would be 3 minus 3, which is 0. All right, once we've determined that, come on. Once we've determined that, we can just go right ahead and solve it. Now, technically what you're doing is you're multiplying both sides by the denominator x minus 3. This is allowed because you're doing the same thing on both sides of the equation, so everything stays equal, but it cancels out the denominators. And then what we're left with is just 3x equals 2x plus 3. And then from there, it's linear algebra. We can subtract 2x from both sides, and we get that x is equal to 3. Oops, but x can't equal 3, right, because that's our domain restriction. That means that this is an extraneous solution. So we're going to want to indicate that by saying it's extraneous or ext. You can abbreviate for that if you'd like. All right, if you want to pause and try this one, it's kind of the same problem. X can't equal a positive 2. We'll multiply both sides then by the x minus 2 to cancel out the denominators. And now we have 5x equals 3x plus 4. And we can go ahead and solve that algebraically. We get 2x equals 4. Divide both sides by 2, and we get that x is equal to 2. But again, x can't equal 2, so this is an extraneous solution. Don't worry, they're not all extraneous. All right, our next example. Now, this is really the same principle, but it does look a little bit different. Looking at this, the only denominator is x, and so that means that x cannot equal 0. So if x is equal to 0, and in the end, then we know it's an extraneous solution. Now, you don't need to do this, but I always like to put my whole numbers and my x's where it's not a fraction. It's just to make everything be a fraction, so putting it over 1. I think it looks a little nicer like that. So then my least common denominator between 1 and x is just x. So each term is going to get multiplied by x. And what that's going to do is it's going to cancel out that 1x as a denominator. All right, now we're going to simplify each term. This one is x times x over 1, which is x squared. We don't need to have it over 1 anymore. Then the 8x over x, the x is canceled out, so this is a plus 8. And then we've got 6 times x over 1, so that is 6x. All right, now we have a quadratic, so we got to remember how to solve quadratics. We want to start by setting this side equal to 0. So that's going to make this x squared minus 6x plus 8 equals 0. And now we've got a factorable quadratic. Two numbers that multiply to 8 but add to a negative 6 are going to be 4 and 2, both negative, so minus 4 and minus 2. And our two solutions there for the x minus 4 is going to be positive 4. And for the x minus 2 is going to be positive 2, because 4 minus 4 is 0 and 2 minus 2 is 0. Double check against our domain restrictions. Whoopsies. neither of those are going to be an extraneous solution, so we've got two good solutions for this one. All right, here's some for you guys to try. And unpause when you're ready. All right, so for 1a, it looks like that. I put the 2 over 1, so all of them are fractions. So between 3x and 1, all of them, or the least common denominator would be a 3x. So I'll multiply all terms by 3x. And now what cancels out? In the first term, the 1 and the 3 cancel out. Then the x and the x cancel out. And now what am I left with? The first term is x times 10. We'll make that 10x. The next term is 4 times 3 on the other side of the equal sign, so that'll be a 12. And then 2 times 3x, that is going to be, that is going to be a plus 6x. And now we've got a linear one we can solve. Minus 6x on both sides. We get 4x equals 12. Divide both sides by 4, and we get x equals 3. Now, I forgot to do the domain restriction. The only domain restriction here would be x can't equal 0. So we have a good solution because 3 does not equal 0. All right, our next one, this one also has x can't equal 0 because of the x in the denominator. Actually, all three of these are like that. This one, our least common denominator is 4x. So the 4x will cancel out all the denominators. All right, so the x's cancel in our first term, the 4's in our second, and the 4's in our last terms cancel out. Now we've got 4 times 6 is 24. 5 times x is plus 5x. And then this is a negative 7. It might be kind of tough to see, so that makes it a negative 7x. All right, and then solving these, it's a linear. There's no x squared, so I can just move the 5x over by subtracting it. We get 24 is equal to negative 12x. And then if I divide both sides by negative 12, I get that x is equal to negative 2. Check it against the domain restriction, which is x can't equal 0, so we're good. All right, and our last one, this one, the least common denominator is just x. So all terms get an x with them. That's going to cancel out the x for that one. Then we've got x squared, x times x. Then 6 all by itself and minus x. Now we can solve this as a quadratic, so we'll move everything to the other side. Now I like to move, technically it doesn't matter, but I want to keep that x squared positive. And I want to rewrite my answer in standard form. It makes it easier to factor that way. So now two numbers that multiply to negative 6 but add to a positive 1 are plus 3 and minus 2. And that is going to give us a negative 3 for the x plus 3 and a positive 2 for the x minus 2, neither of which are going to be extraneous. All right, last set of examples. So now we've got two different, totally different denominators, and there's some, like a factor here in x minus 7. So right away, that x minus 7 will be equal to 0 if x is positive 7. So we can't have positive 7. All right, now my least common denominator here, to get rid of the 2 and the x minus 7, is going to be a 2x minus 7. So we'll multiply there, and then a 2x minus 7 to the middle term, and a 2x minus 7 to the last term. Now let's see what cancels out. The x minus 7's for the first term, the 2's, and then the x minus 7's there. So now our first term, I'm going to totally rewrite this. We've got a 2 times 2x minus 9. The middle term, we've got an x times x minus 7. And then on the other side, we've got a 5 times 2. All right, a little bit of distribution here for both of these. That's going to give us 4x minus 18 plus x squared minus 7x is equal to 10. we can go ahead and combine our like terms and subtract that 10 over at the same time. So if I rewrite this in standard form, I've got an x squared. Then I've got a 4x minus 7x. That is going to be a minus 3x. And then my minus 18 and minus 10 make a minus 28 equals 0. That is going to factor to a minus 7 and a plus 4. And so our solutions, we've got a negative 4 for the x plus 4 and then a positive 7, and that positive 7 is extraneous. So if we're listing both of the solutions, negative 4 is a good solution, but 7, you have to indicate that it is an extraneous solution because of that domain restriction. All right, 2 more. Okay, so the 2a here, that one, the denominator is a difference of squares, so it factors to an x minus 4, x plus 4. So right away, what can't x equal for that one? X cannot equal either positive or negative 4. All right, then each side is going to get multiplied by the x minus 4 and the x plus 4. So that's going to keep things even on both sides. And so on the left-hand side, the whole thing cancels out. Then just the x minus 4s on the right side. So the left side, all we have left is 16, and then there's 2 times x plus 4 left on the right side. So if I distribute, it is 16 equals 2x plus 8. And then if we subtract 8 from both sides, we get 8 equals 2x. And now if we divide both sides by 2, we get x equals 4, which is extraneous because it cannot equal either a positive or a negative 4. All right, and then our last one, x cannot equal positive 1. That would make the denominator equal to 0. And then we can multiply each one by the 6 and the x minus 1. And so what cancels out? The x minus 1 there, the x minus 1 here, and the 6 here. So one side is going to be 6 times 1. Then we've got a 6x. And then if I distribute that x in, I get an x squared minus x. Now if we set one side equal to 0 because it's a quadratic, and rewrite it in standard form, there's an x squared, then 6x minus x is plus 5x, and we've got a minus 6. So that is, in its factored form, going to be x plus 6 and x minus 1. So that is going to give us x equals negative 6 for the x plus 6 and positive 1, which is extraneous for the x minus 1.